Hey guys, Nate here. I thought I'd try something new and write a Python utility tool which can take a CSV file that you have and upload that automatically into a database. Specifically in my case, a Postgres database. So why is this important? Because as a data scientist, you are working with a lot of different data. So oftentimes this data is stored in your database or your team's database, but you're also working with other teams like marketing and sales where they may have their own data in Excel files and CSV files on their laptops or in their own databases where you don't have a connection into that. So oftentimes you're actually grabbing and taking their Excel files, their CSV files, and then uploading it from your computer onto your databases. That will then allow you to take your data and their data and blend them together and run any analyses that you want. What sucks is that that process takes a lot of time, especially if you have multiple CSV files, multiple Excel files to actually upload into a database. That coupled with the fact that a lot of file names are not properly named for a database upload. They may have capital letters, extra spaces, extra symbols that need to be cleaned up. And then in addition to that, the column names also need to be cleaned up. So that could take a lot of time. So why not just automate that whole process? And so that's what I'm going to be creating today. I'm going to be creating a Python script that takes a CSV file and cleans it up and then uploads it into a Postgres database. So it's going to be strictly a first version proof of concept. So a lot of things will be written manually. The next video will be a version 2 of this script where I'm going to refactor all of the code, make it completely automated. So that way I could put multiple files in a directory or folder, run the script without changing a single line of code, and that script will just take every file in that folder and upload that into a new database table without me changing any code at all. That's how you save time and reduce errors as a data scientist. Okay, so with all of that said, let's start coding. All right, let's open up your favorite editor here. I'm using Jupyter Notebooks, but you could also use Google Colabs or Sublime or any other editor that you're accustomed to. So in terms of steps, the first step is to import the CSV file into a pandas data frame, and all of the manipulation will actually be handled there. And then in terms of manipulation, we want to clean the table name and remove all extra symbols, spaces, and capital letters. Basically anything a database can't handle. In addition to that, we want to do the same thing, but to the column headers. Next, we'll write the create table SQL statement and then pass it to the database so that we can create a table. And then we want to import the data into the database. And so that's our last step here. All right, so 5 steps to basically import a CSV into a database. All right, so the first thing we want to do is import the CSV file into the pandas data frame. But before we actually do that, let's just import all of the libraries that we're going to be using today. Import libraries. So the libraries that I want essentially are the OS library. We're probably going to use numpy. Definitely going to be using pandas. So the last library is called psychopg2. It's a Postgres wrapper that will be used to make a connection to our database because our database is a Postgres database. So if I run this, this should all kind of work, and it does. I get that 1 right there. All right, so the next thing I want to do is take a look at my data file, my CSV file. And to do that, I'll just do a magic, an exclamation point, ls, which is a terminal command, a bash command to take a look at all of the files in your working directory. And in there, we have my CSV file here that I want to import to the database. It's called customer contracts. and there's a space in between these two words and there's a $sign, right? That needs to be cleaned up because I can't actually import or create a table with that name. And then this is the file that we're working on right now. It's called CSV import. All right, so we'll ignore that. What's important is actually finding the CSV file here. All right, so what I'm going to do now is just read the CSV file into a pandas data frame. So I'm just going to name this data frame df equals pd.read CSV. And then I will output the head of the first 5 rows of the data frame. So kind of messy headers here. You don't really want spaces or capital letters or symbols like a $sign or a question mark. So what we're going to do next is clean up both the headers and the name of the file, which will become the name of our table, our database table. So the next step is to clean the table name, which is this right here, removing all symbols, spaces, and capital letters. All right, so let's do that right now. So let's say clean table names. The rules that we want for every table name is to basically have only lowercase letters. We also want to remove all white spaces. The third rule is to replace symbols like dashes, slashes, different variations of slashes, symbols with underscores. All right, so let's do that right now. So our file name is actually called customer contracts. All right, so let's actually remove this .csv file here. So let's write a script that will automatically enforce these 3 rules here. Maybe I'll just call it clean table name is equal to the file object, which is this string right here. And in order to enforce the lowercase letters, so basically all letters in the string are lowercase, we're going to implement a lowercase method. And then to remove all white spaces and replace all of these symbols with underscores, we're going to use the replace method, and we're just gonna be chaining them all together for every single rule that we have right here. So the second rule here, remove all white spaces. That one's pretty easy. This is the first parameter in this method is what your original value is, what you're looking for, and then the second parameter in the method is what you want to replace it with. In this case, I am trying to look for spaces, and then I'm going to remove that and replace it with basically nothing, and because there's nothing between these parentheses here. All right, and so now let us do basically the exact same thing, but replacing all of these symbols with an underscore. So that's going to look something like this. So I'm actually going to replace it with nothing. I'm going to remove $signs here. So I'm going to change up the rule a little bit. All right, so here are the rest of my replace methods. So basically what I'm saying is to replace this dash or any dash I find in the string with an underscore, any / here with an underscore, any backslashes with an underscore, remove any percentages, remove any parentheses, remove any question marks. All right, so there's also 2 things I want you to know. I'm using these escape symbols here to just go to the next line so that I don't have one really long line of code. And so this is just a good method if you didn't know how to actually have multiple lines of Python code, so it just looks kind of cleaner. So the second thing I want to note is essentially the use of R. It just means raw string. So I want basically Python to understand that this is a raw string here. Don't treat this as an escape character or any other function. Literally just treat this as a /. So that's what the R means. So once I have all of these replace methods and the lower method implemented here, let's just see if this works. So I'm going to output the new table name, and we forgot to remove the $sign. And I see there's actually a duplicate of question marks here, so I'll just exchange that with a $sign and everything should be good now. So our table that was once customer contracts with a $sign and a space in capital letters is basically now just one word, customer contracts. So if you like how this looks, you can keep it. I actually want to make one change. I want to actually have an underscore between these two words here. So I'm going to replace this rule. Instead of removing spaces, I want to replace a space with an underscore. So if I do that, now I get customer contracts and I know it's two words. It just looks a little nicer and it's a little cleaner. All right, so let's do the exact same exercise, but with the headers here and clean up the headers. Let's just copy some comments so we don't have to rewrite them. Clean header names using basically the same rules as cleaning the table names. So the first thing I need to do is get all of the columns in my data file or in my pandas data frame. And that's just going to look like this. df columns will give me exactly that. And I have an index of all of the header names. So in order to clean up all of these column names, what I need to do is go one by one through this index or through this list and basically implement this rule here or these rules here, right? So I'm going to write a list comprehension that's going to allow me to do exactly this. So it'll be df.columns is equal to, and then I'll start the list comprehension. It's going to look like x dot, and then I'm actually going to just copy and paste everything here because I know it actually works and the rules are exactly the same. And so then I have all the rules, and to finish this function, I'm just going to write for x, which is my object here, which actually are the column names, for x in df columns, which is actually the index or the list here. All right, so hope that makes sense. This is just regular list comprehension. If I run this, let's actually just look at what the output of that looks like. So now I have column names that follow these rules here. All lowercase letters, no spaces, no extra symbols. So this is exactly what I want when I create my column names for my database table. All right, so we're almost there. Let's go back up to steps. We've imported the CSV file into a pandas data frame, cleaned the table names, cleaned the column headers. Now let's actually write the create table SQL statement and then import the data into the database. All right, so the next thing we want to do is create the SQL statement to create our database table. So the SQL statement will look exactly like this. We have create table, customer contracts, which is our table name, and then all of the columns, and then the data type for each column. One thing you'll note is that the data types here actually don't match our pandas data frame data types. Our pandas data frame data types, if you look at our pandas data frame df and just type in d types, you'll notice that in our pandas data frame, our columns have object and float64, but in our SQL statement that we need to create to pass to our Postgres database to create that table, we have varchar and we have float. So what we need to do is actually replace these pandas data types and replace them with database data types. So what I'll do to do that is write a dictionary that has this mapping. Basically, we want to map object to varchar and we want to map float64 to float. So my dictionary is going to be called replacements. And essentially, I'll take the pandas data type, so object, and replace it with varchar. And then I'll do the same with the float64, which is the pandas data type. And then replace it with float, which is what we're going to use in our SQL statement. So these are the only two data types that we have in our pandas data frame and also in our SQL statement. But there are more data types. So what I'll do for completeness is add the other data type mappings. All right, so I've mapped an int64 that we see in a pandas data frame often to an int date time 64 to a timestamp, time delta 64ns to a varchar. So now let's output what the dictionary looks like. And it looks exactly like what we wrote, so I'll leave it as that. this will actually be used to create our SQL statement. All right, so we have the column names here. That's in DF columns. We have the data types converted from a pandas data type to a SQL data type. And the next thing we want to do is actually create this part of the SQL statement. So one thing I forgot to add is that this SQL statement should have commas between them. So it's going to make the code just slightly more complicated. So we want to write some code that will essentially place the column name next to the data type. But the data type needs to actually be a SQL data type. So we are going to be using this replacement dictionary here, and then add a comma, and then do the same thing for the next column, the next data type, and then replace that data type with the SQL data type, and then go to the third column, and then the fourth column, and then the fifth column, and do that every single time. So that's going to look something like this. My variable is going to be called call string for column string. I'll start with the comma. So I'll do comma space. And then I'm going to use a join function to essentially join the column name with the data type. So this is the column name, and this will be the data type. And so now what I want to do is write a for loop that will go through each one of the elements in my list, my column list and my data type list, and then place them together just like I have them right here. So that's going to look like this. We're going to write a for loop here. We're going to zip up df columns with df d types. And of course, remember, the df d types is a pandas data type. We want to replace that with the SQL data types. So I'm going to utilize a replace function to replace d types with our replacements dictionary. All right, so basically, again, what I have is the comma that will separate all of these lines here. And then I'm joining the comma with both the column name and the data type here. That's why I have these curly brackets. And then to place the column name here and to place the data type here, I have a format, and then I have a for loop that will go through each element in my list. And my lists are the df columns list and the df types, d types list. And then in terms of d types, these are pandas data types. So I want to replace that with SQL data types. So I have this replace function and my replacements dictionary to do that. And then I'm zipping them up because I want the column names right next to the d types names. And when you package it up all like that, it becomes one line of code. All right, and so now let's just see what we get. And it looks like we have it exactly right. We have the column name here, followed by the data type. And this is a SQL data type because it says varchar and not object. And then we have the comma, space, and then the next column name, the next data type, then the next column name, the next data type. And so it's exactly what we want. It's just not in, this pretty format that you're seeing up here. But that's fine, because when we actually insert that and pass the SQL statement over to the database, it won't care about formatting. All right, so I think the hard part's done. We basically have the code that will write this automatically for us. The next thing we want to do is establish a connection to our database and pass these SQL statements through. All right, so now let's connect to our database. I am using an AWS RDS Postgres. So that looks like this right here. I am on Amazon Web Services right now. My database is called database.yt, and it's a Postgres database, as you can see here. I would encourage everybody to play around with cloud databases rather than establishing your own local database. The benefits you get when you play around with cloud instances or cloud databases is that it's much easier to set up. A lot of the settings and configuration is completely automatic. It's essentially a one-click setup. and they'll just set up and configure the entire database for you. The second benefit is that these cloud instances are often used in industry. So it's actually something that you could put on your resume if you're trying to find a job as an aspiring data scientist, that you do know the AWS infrastructure or the Google Cloud infrastructure and have played around with databases before. All right, so let's go back to our Jupyter notebook. So now let's establish a connection from this notebook to my database on AWS. And it's a Postgres database, so that means we are going to be using this psychopg2 wrapper in order to establish that connection. All right, so open a database connection. We need first the connection string. So this is basically the address to the database name, the username, and the password to establish a connection to that database. So in my case, the host is the address to the database here. As you can see, it's an RDS on Amazon Web Services. The database name is just called NateDB, the username Nate, and then the password is blanked out. Next thing we want to do is actually establish a connection using psychopg. We're going to pass the connection string. Open up a connection this way. So once we have an open connection to the database, let's just print out opened database successfully. All right. So let's actually just run this to see if we can open up a database successfully. Okay, and we do. So basically I'm passing my authentication over to psychopg2. Psychopg2 is then establishing a connection to the database. So now that a database connection is open, we can start writing SQL statements to that database. So the first thing I want to do is drop tables with same name. So we're just going to drop any tables in the database that have the same name as the table we're about to create, because I don't want any conflicts or errors to pop up. Then I will create the table. And then lastly, I will insert values to table. All right, so let's just work with this one first. In order to drop tables with the same table name, we'll use our cursor, which is our connection to the database, and use the execute function here. We just want to write drop table if exists. Our table name is customer contracts, right? So I'll type in customer contracts. So now let's see if this works. It works. There's no error that popped up. All right, so the next thing we want to do is create our table. We're going to use essentially the same functions here as this drop table command, but we're going to delete this command and write our create table SQL query. So that essentially is going to look exactly like this right here, where we have a create table, customer contracts, and we have this part right here, right? But this part is actually right here. That was all the work we did to take the column names and put it right next to a SQL data type instead of having a pandas data type. So what I'll do next is copy this part of the SQL query into our create table query. So that's going to look like this. Here we have create table customer contracts, and then I've just essentially copied and pasted this whole thing down here. So this entire create table SQL query matches the syntax of what we originally wanted here. All right, so if we execute on this query, it says current transaction is aborted, commands ignored until end of transaction block. I think we just maybe need to open up a database connection again, drop any tables that are the same, and execute the create table, and it looks like we have it right. So sometimes when you're working, the connection can close. You just need to open it back up again and re-execute all of your code. So now we've created our table, customer contracts, in the RDS Postgres database in AWS. The next thing we want to do is insert values into that table. So inserting the values, there's going to be multiple steps to do that. It's not as simple as just writing an insert SQL statement. So the first step is actually saving your pandas data frame to a CSV file. So all of our data right now is stored in a pandas data frame. We are going to save that to a CSV file, and we're going to use that CSV file to then upload to the database table. So then the next thing after that is to open the CSV file, save it as an object, and upload to DB. So let's just start with this first one here, where we're going to save the data frame to a CSV file. So we're going to take the data frame object df and utilize the toCSV function here. So let's name our CSV file customer contracts.csv. The headers we're going to use are df columns. We don't want an index, so we don't want to copy the index column from our pandas data frame into our CSV file because that's actually not needed. And then lastly, we want to enforce UTF-8 encoding. So that's just the encoding that is used. A lot of times if you are taking an Excel file, you can have different encodings that will just mess up the import. You'll have like strange little symbols when you try to import the CSV file to the Postgres database or to any database. So we're just going to enforce the encoding and say that the CSV file that we're creating right now, we're going to have UTF-8 encoding. So now we want to open the file. To do that, I'll just create a variable called myFile, open, and then the file name. So it should be customer contracts.csv. And if this is successful, I'm just going to print file opened in memory. All right. So it's basically taking the CSV file, opening it up in your RAM, and then preparing it to actually insert into your database table. So let's just run this code block to see if everything I've written works. And nope. Keyword argument here, headers, I think it should actually be header. So now let's try again. File opened in memory. So this is all correct. So we opened the CSV file, we saved it as an object, and now we need to upload to the database. So I'm just gonna bring this down here, upload to DB. So upload the object, upload the CSV file to our database now. We need to create our SQL statement. And it's not as easy as just writing an insert SQL statement, because we have the file opened in memory right now. That file is an object. So we want to actually copy that entire object and all of its values into the database on AWS. So the SQL statement is actually going to look like this. I'm just going to create a variable called SQL statement that will store the entire statement. So copy customer contracts from std in with CSV header delimiter as comma, because it's a CSV file, comma separated values. So basically what the SQL statement is saying is copy the CSV file that you have open right now. It has headers, it has commas as delimiters. Copy all of those values to your table called customer contracts. All right, so this is the SQL statement. And so to execute that SQL statement, we want to use cursor copy expert. The SQL statement will be this up here, SQL statement. The file that we want to copy, I have it up here as my file. That's the file opened right now. And once that's copied, I want a print statement that says file copied to DB. All right, so let's see if it works. So it looks like it works. All right. One thing I do want to do is I want to change the permissions of the table so that it's open to public, so that it's basically open to anyone that has access to my database. So this is completely optional, but there can be permission issues when multiple users try to access that table in your database. So in order to grant multiple users access, I'm just going to change the permissions of that table. So cursor execute grant select on table customer contracts, that's the name of our table, to public, so that anybody that has access to our database, to my database, can actually access the data and access the table. Oops. Commit this code. And then when I'm all done with everything, let's just close the connection. Close the database connection here. And when that's done, let's print table customer contracts imported to DB completed. All right, so the last thing is to actually check if the database table was created and all the values were inserted into that table. So I'm using a database ID called DataGrip. It's just basically a platform that allows me to connect directly to my database. If you're using a Postgres database and it's locally installed, pgadmin is another software or another platform you can use. So in order just to check to see if I have the table created and the values are there, let's just do a select from customer contracts. That's the name of our table. And it looks like we do have it. We have customer contracts, our table, the header names, all reformatted so that they're all lowercase letters. There's no extra symbols, no extra spaces. And then the data got uploaded as well. All right. So this is essentially how you upload a CSV file to a database, specifically in this case, a Postgres database. So as mentioned before, all of this stuff is pretty manual. I'm typing out the name of the CSV file here. I'm typing out the name of the table that I want to drop in create. I'm typing all of this out, or copy and pasting all of this out, typing out the name of the CSV file that I want to save and then upload as an object. So all of this manual work is okay as a first version, as a first iteration, to prove out the MVP, to prove out that this actually can work. The second step as a data scientist, especially if you're working in teams or working on a job, is actually to automate as much as possible so you're not at all editing or refactoring any code. So in the next video, what I want to do is just refactor all of this code, make it as general as possible and as automatic as possible so that when you want to upload any CSV file or multiple CSV files, we can do that by just dropping the files into a directory, into a folder, running the script, not changing a line of code, and just having that automatically upload to your database tables. The benefit of doing all of that automation work is that it'll save you a lot of time, especially if you have multiple CSV files, and it will reduce or eliminate any errors that you could make when you actually manually start typing things out, because everything's just automatic at that point. So if you want to see how that goes, subscribe to this channel right here and you'll be alerted when I release that video in a few weeks.